Okay, hello everybody. Thanks for taking the time to watch the video here this morning. So we are going to be starting into chapter 2, section 4. And this particular chapter and section has mostly to do with what the parent functions are and how we use them to sketch graphs. What the parent functions are is they're a collection of very commonly used equations and graphs in algebra. And so what you see is there's going to be 8 of them, and I'm going to kind of go over each one and discuss each one in detail. So this first one is called the constant function. An example of this would be something like not even y, I'm not going to use y, we need to use f of x. F of x equals, let's say, 3. Right? So it doesn't matter what the x input it is, the output would always be 3. That's going to be simply a horizontal line across. It's one of the basic types of functions that we can have. That constant function, I want to talk about the domain and range also. So the domain of that function, remember, that's how far left and right this goes. Well, because that function goes to the left and to the right forever, the domain is going to be negative infinity to positive infinity. Now, the range of that function is going to be how far up and down that function goes. Now, this one's a little bit tricky because it really doesn't go up or down. It stays at one constant level. That's why it's called the constant function. So the domain or the outputs of that function are very dependent on what the constant is, what the c is. So in general, the domain is negative infinity to infinity, but the range is simply going to be with squiggly brackets listed as the number c, and c is whatever the output number is. Now, the next one is called the identity function. This one is very simple. It is just f of x equals x, or if we weren't using function notation, it'd just be y equals x. And what that means is whatever number you put into that function is the number that you get out. That's why it's called the identity function. So this one is a little bit more straightforward as far as the domain and the range go. Okay, the domain, how far left and right does this go? You can see it goes to the left forever, it goes to the right forever. So the domain is negative infinity to infinity, and the range is also negative infinity to infinity because it goes up and down forever. The third parent function we're going to take a look at is called the absolute value function. And I know it's probably been a while since you've looked at a graph like this, but this is what an absolute value looks like. And the reason why there's nothing down here and there's nothing down here is, remember, below the x-axis, the y values are negative. The whole point of the absolute value is it eliminates negatives and only allows positives as outputs. So let's think about what numbers we can put in. Domains are numbers that are inputs, range are the numbers that are outputs. So what numbers can we put in? Or how far left and right does this graph go? Well, it goes to the left forever and it goes to the right forever. Thus, it means that the domain is any x that we want. We can put any number we want. So it's negative infinity to positive infinity. Okay. Now the range is a little bit trickier because, as you can see, this graph doesn't go down forever. It's capped and it stops right there at the origin. So you think about what that number is, what the y value is, that's 0. The reason why it stops right there, as we said, this is the absolute value. It takes negative numbers and makes them positive. You can't get a negative number out of this. So the range, it goes up forever, but it is capped on the bottom. So the minimum that value that will come out of that graph is 0. And then it goes on to positive infinity. Now, here's the thing. The 0 has a bracket because we can get the number 0 out of the function. If I plug the number 0 in, the output I would get would be 0. So it does reach 0. It just doesn't go any lower. So it is a bracket. Okay. Now, the last one in this first group of 4 is called the square root function for obvious reasons. The function itself square roots the numbers that you put in. So kind of similar to the last one in that you only get numbers that are positive or 0 that come out. This one has a restriction similar to that, but it's actually on the domain instead of the range, which it actually is on the domain and the range. But if you're looking at this, what numbers, you think in your head, what numbers can we square root? Well, the answer right here, the only numbers that we can put underneath that square root are going to be 0 and positive numbers. We cannot put negative numbers in. And that's why you don't see the graph extending over here where the x's are negative. So the domain for this is going to be bracket 0 to infinity. So you can put anything you want from 0 and including 0, which is why it's a bracket, up to infinity. And infinity means it goes on forever, so you never really get there. The range is going to be similar. You can see right here how far up and down. It starts at 0, and this graph continues to climb, and it will climb forever. So the range is also 0 to infinity. Move my screen there so you can see that. Okay. Now, the next group of 4, 2 of these are very strange, which we'll talk about here in a second. This is called the quadratic function. This should look familiar to you. It's simply the graph f of x equals x squared. It is a parabola. The domain and the range for these, the domain is easy. You can put whatever number you want in for x squared and square it. And you can tell that because this graph continues to get wider and gets to the left and the right, it gets wider and wider. There's no bound to how wide that graph gets. So the domain is negative infinity to infinity. But the range is limited somewhat. And the reason why it's limited is when you square a negative number, it can't ever be negative. It's going to be positive. So you can see this is capped. The lowest that this graph goes is 0, and then it goes up from there. So the range does include 0 because if you put a 0 in, you can get a 0 out, and then goes up to infinity forever like that. So 0 to infinity. The next one is called the cubic function. It is very similar to the squaring function or the quadratic function, except that when you cube a negative number, you get negatives out of it. So if you look, this graph does continue to widen as it goes down, so it will get wider, and it will get wider this way. So there is no bound to how wide that gets. It gets wider and wider and wider. So the domain of this function is negative infinity to infinity. And the range of this function is also negative infinity to infinity because it goes down forever and it goes up forever. Now, the next two are a little strange, okay? This one is called the reciprocal function. And what I want you to notice is there is a gap in the graph right here, and there's also a gap in the graph right there. So those gaps occur on the x-axis and the y-axis. So they're skipping over. The graph gets really close to the x-axis, then jumps up and then goes up like that. So it never actually reaches the x-axis and it never reaches the y-axis. So there's a gap there when x is 0 and when y is 0. And the reason being is, the most basic reason is x cannot be 0 in this function. Because if you do, you'll be dividing by 0, and then that violates a pretty basic math law, which is you're not allowed to divide by 0. So for the domain and the range, we have to exclude 0 from both of those, from the domain and the range. So how do we do that? Well, if you recall, I had shown in class, if this number is 0, we want all the numbers over here and we want all the numbers over here. There are two separate sections on that linear graph that we need to account for when we write the interval notation. So the domain is going to be negative infinity to 0 union 0 to infinity. So basically what that's doing is it's starting from here, it's going over, skips over 0, and then keeps going. Okay, the same exact thing for the range because it also skips over 0. So negative infinity to 0 union 0 to infinity, just like that. Okay, now the last one is the weirdest one of them all, and it's called the greatest integer function. And I'll explain how this one works a little bit later when I give you an example. But what you see is it looks like a set of stairs. So they'll call this the stair step function because it does. It looks like a set of stairs. Thing to keep in mind is this is very important that you start with an closed dot and then end with an open dot. That matters and as we get further into this, I'll explain that. But what you want to see is what the domain and range are. Now, the domain for this function is how far left and right does it cover? Well, if you look, it covers everything from -3 up to -2, but then this takes over right at -2 and goes up to -1. This takes over at -1, goes to 0. This takes over at 0 and goes over to 1. So even though it's disjoint, it is covering all of the x values from left to right. So the domain is actually -infinity to infinity. You can put whatever you want in for this x value right there. Now, the range is a little bit different. The reason why it's called the greatest integer function is this function always rounds numbers down. So if you put the number 2.5 in there, it would round down and the output would be 2. If you put the number 2.9 in there, it would round down to 2. It's taking the greatest whole part of a number out. So what that translates to is, though, you only get integers as the output. You can see the y value would be -3, -2, -1, 0, 1, 2, 3. So you're only getting integers as the output. So your range for this one is just going to be a squiggly. You don't even need to do the squiggly. You can just write. It looks like a very thin Roman numeral 2, but what it is it's like a boldface I, and that I stands for integers. If you would rather just write the word integer, that's perfectly fine as well. So it says familiarity with the basic characteristics of these simple graphs will help you analyze the shapes of more complicated graphs. In particular, graphs obtained from these graphs by the rigid and non-rigid transformations, which is one of the things that we're going to be doing next, which is how to manipulate those graphs and fit more complicated equations. So the linear and square. So this proceeds to go through and actually explain to you each of the graphs, which you'll see here in a second. But I want to give you an example first. So this one, the example says, write the linear function f for which f of 1 equals 3 and f of 4 equals 0. So this is a really a very early type of problem you would have done a long time ago in Algebra 1. So this is probably going to be a little bit tricky for some of you till you kind of catch on to what we're doing. But what they're giving you is they are giving you ordered pairs. There's our x, there's our y. Okay, here's our x, there's our y. So they gave us two ordered pairs, 1, 3, and then they gave us the point 4, 0, and they want us to write an equation of a line that goes through those 2 points. So if you recall, in order to write the equation of a line, you need a point and you need a slope. So the first thing we're going to do is find the slope by doing x1, y1, x2, y2, and then we proceed to do the formula for slope, y2 minus y1 over x2 minus x1. When we simplify that, you can see our m is equal to -1. Now that we know that the point, we have 2 points, and we know the slope is -1, we can write the equation of a line. I'm going to use point slope. The reason why is slope-intercept is great if you know the y-intercept. We do not know the y-intercept. We just have a couple random points. So I'm going to use the points that we have. I'm going to use the slope that we calculated to write an equation. So y minus y1, so y minus 3 equals -1, that's my m, and then x minus x1, which is 1. I am going to distribute the -1, and then I'm going to add 3 to both sides. And I get my equation right there. Y equals -x plus 4. That equation will run through the 2 points that we had from up here. And there's a graph of the equation that we solve for. Now, the next bunch of slides go through and explain the different types of functions. So here is the constant function and then the identity function. And you guys can take the time to read those if you want. That's why I always post the note packet on Google Classroom. This is the squaring function. It talks about different characteristics of it, which I basically covered mostly whenever we were writing the domain and range of each of the functions. Okay. So this talks about the cubic, the square root, and the reciprocal functions. And again, you can read those if you would like, which is why I included the packets on the Google Classroom post. So that's what I have for you today. I hope that made sense. And as always, if you have any questions, feel free to email me. Have a great day.